Welcome back to a new video. In this video we will discuss some algebra operations useful for science and engineering specifically. So we will see how we can use the rules for specific examples also. So let's see what the outline is for our video. First we'll look at arithmetic rules, specifically also useful for later. We will see how we can use the operations using fractions, and we'll also look at powers. And finally, we will look at factorization. And each part we will see examples also. Okay, first one is the arithmetic rules. We have an addition, so simple addition, and there are two laws. We have the commutative law and the associative law. The commutative law means actually straightforward the following: A plus B can be also written like B plus A. That means also for three different parameters, so A plus B plus C can be also in a different order like so, and like so in a different order. It doesn't matter actually where you start, where you end, if you just add them up. Okay, now these are the variations if you have three different parameters. Now we can also have associated law, which is then having the parentheses, for example, here, but that parenthesis doesn't have an effect for the addition. So we can just move the parentheses and also remove the parentheses because there's just simple addition. In this case, we can have A plus and then parentheses B plus C, but you can also move that parentheses for A and B together and then plus C. Now that is for this law, but we have also another example, for example, C plus and then the A plus B in parentheses that can be also shifted like so. And we have also without the parentheses, so everything is actually here equal to each other. Now the multiplication is also in two different laws, so commutative and associative. So we have A times B, so the dot means here multiplication. But you can also do that just B times A, like 2 times 6 or 6 times 2. It doesn't matter, the result will be always 12. The associated law is for parentheses, and also here the same result will be applied. We see here C times and then parentheses A times B, but you can also move that parentheses here like C times A and then times B later. But you can also just do A times B times C. Most of the time we drop that dot notation for the multiplication because that's just a little bit more work. So we just say A times B times C like so. That is automatically understood that you have a multiplication here. So you can also say A times B by doing AB, or ABC means A times B times C. Okay, we can also combine the multiplication and addition and subtraction. So we have also again the different law. So in this case the distributive law. What does it mean? We have now an A and then times B plus C. In this case the parenthesis is important. Now if you work that parenthesis out, you can do A times B, that's first one. And then A times C, so we work out the parenthesis like so. You can also write it down again without the dot, so we can have just simple AB plus AC. Now, we can also use the minus sign instead of a plus sign. That's straightforward business was also applied here. So we see here just exact same, only change is the minus sign. Now, we can also have a division and addition and subtraction all together. Now, we see here A plus B together in parentheses and then divided by a C. Again, we do here two parts. We do here first A over C, that's shown here, and then B over C, that's shown here. Of course, plus in between because there's a plus here. But most of the time we don't use this symbol. We use just a fraction symbol, which is just this symbol here. So it is A over C and then plus B over C. This is most often used. Of course, you see this symbol in your calculator. You can also have it for a minus sign instead of a plus sign. Straightforward business also is applied there. So A over C and then minus B over C, of course, like so. There is an important note here, so I would like to warn you about that. This A and then divided by the combination of B plus C is indeed this, but this is not equal to this. So don't say, for example, because we say it here, a plus b together divided by c, we just split that in two parts, like so, a over c and b over c. That's allowed because we have here first the parentheses and you divide it by this parameter. But now we do the reverse, like so, just a here and then divided by the two parameters here in parentheses, but you don't do a over b plus a over c. This is not correct. So you can also check it for yourself. You can also put here some numbers and see that this is indeed not equal to each other. Okay, now we need to see some numbers, so examples. So we use now numerical examples to illustrate the concept. So let's go one by one. A plus b is equal to b plus a. That means 2 plus 4 is equal to 4 plus 2, so just 6. So we know that this is indeed correct. For the other one is a plus b plus c. We can just do here again simple calculations using some examples. For c in this case I have 5. But it is also equal to 2 plus 4 plus 5. So this is also like so, and the result here is 11. Now, similar case for the multiplication. You see here 2 times 4, for example, but then also 4 times 2. That's all 8. And also multiplication of 3, 4, 5. It doesn't matter. You can multiply in as much as you want. The multiplication will be just straightforward. All of them multiplied. There will be in this case 40. Now this is the result for the distributive law for multiplication, addition and subtraction. Now in this case first multiplication and addition. You see it 2 times 4 and then 2 times 5. You can do that separately. You can do it like, okay, I do 8 plus 10. Because this is 8, this is 10, so it will be 18. But you can also say 2 times 9, which is also 18. So that's also possible. In this case, we just do minus sign instead of plus sign. So we have now 2 times 4, this will be 8 minus 10. It will be then minus 2. But you can also say this is minus 1. So 4 minus 5 is minus 1. Times 2 will be also minus 2. So sometimes it depends how the expression is written. So sometimes it goes faster to look at it actually in the original form. Okay, now the example for this situation where you have a division. In this case we have 2 plus 4 for a and b, and you will divide by c, which is 5. In this case you can also again divide the problem like 2 over 5 plus 4 over 5. You see that here, which is actually effectively 6 over 5. So 6 over 5 would be 1.2. This is 2 over 5 is 0. This is 2 over 5 and this is 4 over 5. So 0.4 and 0.8, there you get 1.2. Now the other one with the minus sign, we have now 2 minus 4 together over 5, which is, this is already minus 2. So you can also say minus 2 over 5, but you can also divide it in two parts, like 2 over 5, like so, minus 4 over 5. And you can have here 0.4 again, so 2 over 5 minus 0.8, that will give you minus 0.4. But you can also do it right away from the start, like minus 2 over 5 will be also minus 0.4. Okay, that's for the first rule. Now we will look at the fractions. Now we have addition of two fractions, for example, a over d. These are symbolics, and b over d. So we see here the same denominator, so we can combine them. So we have a plus b over d. Now let's do an example right away, because that's handy. So let's say this is 6 and b is 4, but d is 2. So that means we can take them together, like 6 plus 4, that is then here 10, over 2 will be then 3 plus 2 is 5 in this case. You can also look at it actually in separate form, like 6 over 2 was already 3 and 4 over 2 was 2, so together is also 5. So left side and right hand side are equal to each other. You can of course combine that with 3 fractions or 4 or 6, it doesn't matter, as much as you want. And again, the important thing is that the denominator are all the same. So if this is 2 to 2, for example, that is possible. But if this is 2, this is 6, this is 9, you need to make that the same. So we have now a plus b plus c all together. And now we have here, for example, again, this example, 6 plus 4, in this case c is an 8, so we can do that like 3 plus 2 plus 4 from here, 3 plus 2 plus 4, or you can do it from here, which is 18 over 2, which is then in this case 9 exactly. Now we can also subtract here two fractions in this simpler form. Actually, this is really a small change. The plus sign will be a minus sign, so all the laws and steps are exact same. So 6 minus 4 instead of 6 plus 4, and then you have here exactly 1. So 3 minus 2, because this is 3, this is 2, and then you have 2 over 2, which is 1. You can also do it with 3 parameters or 3 fractions, so a minus b minus c over d again, because d is exactly the same for all fractions. Now we have this one, and that will result in this case for this situation minus 3. Now we can also multiply. This is actually the easiest part for fractions. So multiplication of fractions is the fastest and the easiest. So a over b times c over d is really straightforward, like a times c in the numerator, so in here, divided by b times d times c. So this is actually really simple. That means the following is actually here 6 over 4 times 8 over 2. So we have an example here. That means 6 times 8, just in the numerator, divided by 4 times 2. So what's the result here? Now we can just calculate this. This is 48 over 8. And that is exactly 6. But you can also look at it in a different way. You can say, hey, this is already 6 times 8, but this is also 8. So you can divide out 8 and 8, so that will leave you the 6. So you can also look at it in that way. Now you can also multiply again more than 2 fractions. So a over b times c over d times e over f. You can see that also here, a times c times e divided by b times d times f. And now here again a numerical example using e and f as new values. We have here now 240 over 24 will be 10. And again, you can look at it here in much faster way, like so, because this is 6 times 8 times 5, but this is also 8 here. So this 8 and this 8 will cancel each other out. We have then here 6 times 5, which is 30, over 3 will be exactly 10. So sometimes that goes much faster instead of multiplying this together and getting large numbers, and then again from here getting the end result will maybe take some time. Okay, now the division. The a over b divided by some number. So we have a fraction and we divide by number. That is really this case. You do actually your fraction, you divide that also by c. So since this is just one parameter, you just put it also in the denominator. So we have here a over b times c here. Now let's see an example. That's always handy. So 6 over 4, for example. But you divide by 8, and you just put this 8 also next to that 4, so it will be then 6 over 4 times 8. So 6 over 32. That is then in this case 3 over 16, which is then 0.1875. You can have also fraction divided by another fraction. Now in this case you see that c over d, which is the second fraction, where you divide to 2, that will be then flipped in the multiplication. So you see here a over b times the inverse of this one, which is not c over d, but d over c. And then this result where we see the multiplication is also applied here. So then you have just a times d over b times c. So let's see an example. 6 over 4 over 8 over, I divided by 8 over 2. That means 6 times 2 over 4 times 8. So it is then 12 over 32, and that will result in 3 over 8, which is then 0.375. Okay, looking now at the powers, which is also important in many applications and calculations. We have, for example, an unknown x, which is a parameter that is to the power a, and we have exact same x, but it's 10 to the power b. We can simplify this, since this is exact same, the x and an x, by doing that x to the power a plus b. Again, let's look at an example. So x to the power 5 times x to the power 2, so x squared will be then x to the power 5 plus 2 will be then x to the power 7. If this is a negative number, by the way, for example 5, and this is the minus 9, for example, it doesn't matter, so we'll do 5 minus 9 will be then here minus 4. So you just add them up, the two parameters here. You can also do it with 3, a, b, c. The straightforward calculation is like so. And then you have here 5 plus 2 plus 3. You get here x to the power 10. You can also divide it actually. So instead of multiplication, you divide it then. In this case, you divide the parameters as a minus sign here in the exponent. So you do x to the power a divided by x to the power b will be then x to the power a minus b instead of a plus b. That's the only change. Now let's do an example here. We have x to the power 5 over x squared will be then x to the power 5 minus 2 will be then x cubed. Now we can also do that with a combination of powers, so x to the power a times x to the power c, which is this. You see here actually that the dot notation is gone because that is understood that this is a multiplication, and x to the power b and x to the power d is in the denominator. Now what you see is, since these two are in the numerator, so they will be added up, and these are in the denominator, so you need to subtract them. Now let's see an example. You see here a and the c, like 5 and 3, and the b is 2 and d is a 4. So you do 5 plus 3 minus 2 minus 4. This is only valid if all the parameters like x, x, x are exactly same. Okay, so we have here, that means it will be then x squared. All right, now let's move on to the multiple powers. So what does mean multiple power? You have actually an x to the power some power, and that also to the power. In this case, it is pretty straightforward. You do just x to the power a times c. So not addition, but you do multiplication of these two parameters a and c. So let's see an example. We see here, for example, x to the power 5, and to the power 3 will be then x to the power 5 times 3, which is then x to the power 15. You can also have two parameters like x and y with different parameters here in the exponent. So two unknowns, x and y, to the power a and to the power b. Different parameters, but all of them to the power c. So you just do for each of them c multiplied in the exponent and also here. So let's see an example. X to the power 5 times y to the power 2, so y squared to the power 3 will be then 5 times 3 here, and 2 times 3 here will be then x to the power 15 times y to the power 6. Negative powers, so these are also important, most often encountered. So x to the power minus some number can be also written like 1 over x to the power the positive of that number. So if this is, for example, x to the power minus 4, will be then 1 over x to the power plus 4. You can of course reverse the process. You can say if this is, for example, x to the power 7, then it will be then 1 over x to the power minus 7. So just if you divide it by, you need to invert this sign. Okay, now here's an example, another example, but just numbers, not in a parameter. You see here 2 to the power minus 1 will be then 1 over 2 to the power 1, which is just 2, of course, so 1 over 2, which is half. Now fractional powers, also important. What are those? Now you can also have a power which is fraction, not just a number, so a over b, for example, a fraction. That can be also written like a square root. So you can have this b, which is going here, and that a is an exponent for that parameter x. Let's see an example. Now, for example, if you have an x to the power 3 over 4, you can put that 4 here, which is then 4th order square root, and this 3 will be then the exponent of that x. Another example is using this minus sign, so everything stays the same. The only change here is this minus 3. But we know x to the power minus 3 is like x to the power minus 4 will be then 1 over x cubed here. So that can be also written like so, which is a bit more easier to read and more compact. Now this is a format we see most often in calculation, so x to the power 1 over some number which is automatically square root with this power, which is then here b. So if this b is, let's say 5, we put here 5 here, and it will be then just x to the power 1, but x to the power 1 is always x. That means this is then the b square root of x. Let's see an example. So x to the power and half is the square root of x to the power 1. In this case there's a 2 here, but that's automatically the standard square root. But if you, so you can just drop off that 2, you can also drop that 1. So in total, effectively, this is the expression. You can also have x to the power 1 over 3, which is then the third order square root, will be then x to the power 1 again in the square root itself. That will be, of course, just x, so you have now this simplified form. So you can just extend that to 1 over 4, exactly the same, or 1 over 5, doesn't matter. So in general, you can use this expression for converting that to this square root symbol. Now let's now look at the factorizations. These are also important steps to simplify the calculations. If you have, for example, 5x plus 10, so 2 parts, you can also combine them and make it more compact by doing 5. So you just take out the 5 because that is a common factor, so that is a common, they have both a 5 here, and that will be then x plus 2, because this will be then 5 times 2. So then if you divide it, if you just work it out this, you get the exact same here. So the left side and the right hand side are now equal to each other. Let's see another example. So for example, 9x plus 27. So we see here the 9. But here in 27 you have also 9, which is 3 times 9. So you can also say, let's put the 9 out, and then in parentheses x plus 3. You can also have it like this. This is a little bit more complicated. So you see here 24x plus 6. Now in this case you cannot see here at 24, but we know that we can make this 24 if we, for example, divide the 24 over 6. That will be then 1 over 4. So if you work it out, you can see this. If I want to take out 24, if I decide that out of my parentheses, and that will be then 24, and the parentheses over will be then x plus, and this number will be then such that if I multiply it by 24, will need to produce that 6, which is then 1 over 4, or 24 divided by some number needs to produce that 6, which is then 4. Now you can also have a quadratic expression, which is this expression. This simple expression, which will only have 2, so the square part and the linear part. Each of them have an x, so we can just put x out, and then we do here x plus 5. And this is also similar to that one, but using the quadratic expression. You can also have 3 parts, so the x squared plus 2x minus 8. In this case, you can have 2 parentheses. Now you need to look at the 2 numbers here. You need to actually find it out. There will be a unique set. The product of these 2 will be minus 8, and the summation will be plus 2. So you need to find in your head, there are 2 numbers, will be multiplied, will produce minus 8, and will add up, will produce plus 2. And this is in this case 4 and a minus 2. There is no other variation, by the way. This is the only way to do that. If I change this to minus 9, it doesn't mean that you have also this nice parenthesis. It cannot be always the case. So it needs to be, you need to have it in a nice way. For example, another example is here. For example, x squared plus 9x plus 20. In this case, again, we look at 2 values multiplied will be 20, but added up must be 9. So I can say, okay, multiplied 2 times 10, for example, but if I add them up, that will be then 12, so it doesn't work here. We can do maybe 4 times 5, which is also 20, but 4 plus 5 will be 9. So that is indeed the result. So x plus 4, that is an x plus 5. So you see here the result. If you want to be sure, you can also work this out, and you can get this result back. Now there's also another form where you also have a parameter which is, or a, let's say, coefficient which is not 1, but let's say 4, another one, so other than 1. So for example, this one, 4x squared plus 12x plus 8. So what do we do in this case? Now, in order to use this method, first we need to try to work out here such that we have only x squared plus x plus some constant. So we can take out the 4 here, because this is 4. If I also divide this by 4, it will be just 3, and this is then 2. So I get actually this one, which is exactly the same as this one. So this is equivalent to that one. But this is handy because I can now just leave that 4 out and focus on this part and use the method I have also explained here. So again, x squared plus 3x plus 2. So why can we do that? Now just leave that 4. So x plus 2 times x plus 1. Why? Because this is a product of two numbers, and those two same numbers added up must produce 3, which is then 2 and 1, or 1 and 2, doesn't matter. So the order is also not really relevant. Let's see another example where you also see a quadratic expression, but in this case we see here squared and then a constant term. So x squared minus 16, in this case that will result in x minus 4 times x plus 4. If this was, for example, x squared minus 15, then I need to have here a square root of 15 and plus square root of 15, which is of course not a nice number. So in this case I took an example where you have right away 4 times 4, which is then that 16. So with the number which you put here needs to be a square root of that 16. Let's see another example. X squared minus 81. The square root of 81 is 9, so that means x minus 9 times x plus 9. Again, if you work it out, you can see that this is the result. And the final example is about the x squared minus 121. Again, look at the 121. The square root of that 121 is 11, so that means x minus 11 times x plus 11. Alright, that was our series of examples discussing the basic algebraic operations. If you have any questions, comments, please let me know. I will try to answer them as soon as possible. See you next time in another video.